Imagine the fallout on a factory floor when a sales VP just, casually promises a key enterprise client 50,000 custom units by the end of the month.
Oh, I've seen it happen. It is pure panic.
Right. I mean, the plant manager is just standing there staring at the equipment, doing some quick mental math on machine hours, and, well, factoring in maintenance downtime, they realize the absolute maximum physical output is maybe 30,000 units.
Yeah, and that massive high-speed collision between those corporate revenue dreams and the unforgiving laws of factory floor physics, that is exactly where the master schedule lives.
Exactly. So welcome to today's deep dive, where we've tailored a specific look just for you into Module 4, Section C of the APCTS CPM material.
And we are focusing entirely on creating the master schedule, which, it sounds like dry administrative work, but it really isn't.
Not at all. It's really the central nervous system of any manufacturing operation.
Yeah.
Because it's the ultimate reality check.
Right. It absolutely is. I mean, you have this constant underlying tension between what a company wants to make driven by sales targets, market dominance, those big growth projections, and what it actually physically can make.
And when we say what they can't make, we're talking about the hard limits of capacity.
Right. The literal hours in a day, the specific machines available, the labor force you actually have on hand, and the raw materials needed to pull the whole thing off. The master schedule serves as that bridge between the strategic boardroom and the tactical shop floor.
Yeah, and to really understand how that brig is built, we have to look at the ecosystem it sits inside. I mean, the master schedule doesn't just operate in a vacuum.
No, definitely not.
It's part of a very specific downward-flowing business planning hierarchy. So you start way up at the top with S&OP, sales and operations planning, and then that flows down into master scheduling, which then flows down into MRP, or material requirements planning.
And the key difference between those levels, which is super important to grasp, is resolution and frequency.
Right, like zooming in on a map.
Exactly. So S&OP operates at a really low resolution. It looks at the big picture, dealing with overall production volume and broad product families, and it operates on a monthly cycle. It represents management's consensus on total units to be sold and produced.
But then master scheduling dramatically increases that resolution.
Yeah, it drops down from those broad product families to the specific product mix and actual end items. And it operates on a weekly or sometimes even a daily basis.
And what really stands out in the CPI materials, and I think this is crucial, is that this downward flow of demand planning, it isn't just a wish list.
Great.
It can't be. For every single demand-side plan in this hierarchy, there's a corresponding mandatory capacity check on the supply side. So S&OP is checked against resource planning, master scheduling is checked against rough cut capacity planning, or RCCP. And down at the MRP level, you check against capacity requirements planning, CRP. You are constantly pairing the demand plan with a physical reality check at every single magnification level.
Because if a company skips those capacity checks, they aren't actually planning. They are just hoping.
Yes.
To put this in perspective, think about the cascading logistics of executing a massive event, like a high-stakes corporate banquet.
Okay, let's unpack this. So the S&OP level, that's like the initial catering contract, right?
Exactly. The event planners agree they need to feed 500 people either a chicken or beef dish next month.
And the resource planning check is the catering director looking at their facilities and verifying they actually, lease enough commercial kitchen space and own enough ovens to cook 500 meals at all.
Right. And then you step down to the master scheduling level.
Okay, so the master scheduler dictates that the kitchen needs exactly 250 plated chicken dinners ready to serve by 6 p.m. on Tuesday.
And the corresponding RCCP, the rough cut capacity planning check, involves verifying the specific bottleneck resources.
Like asking, do we have stove number 3 open and available exactly at 5 p.m. to fire those 250 pieces of chicken?
Yes, exactly. And finally, MRP takes over. Material requirements planning looks at that requirement for 250 chicken dinners and explodes it into the raw ingredients.
So it calculates the need for like 500 carrots, 50 pounds of potatoes, and 250 raw chicken breasts.
Right. And the CRP, capacity requirements planning, verifies the granular labor and equipment needed for that specific prep work. Like checking if there are enough pup cooks actually scheduled on Tuesday morning to peel all those potatoes and chop those carrots.
I love that analogy. It makes it so clear. And the master schedule sits directly in the middle of that whole hierarchy. The source text essentially describes it as a shock absorber for the entire organization.
What's fascinating here is that without that shock absorber, the system just tears itself apart.
Oh, for sure. Because at the top, the S&OP is making these broad promises to the market. But the shop floor has to deal with the friction of reality.
Exactly. The master schedule has to resolve the immediate trade-offs between maintaining customer service levels, maximizing production efficiency, and minimizing inventory costs.
It ensures those lofty promises made in the S&OP boardroom don't completely crush the factory floor.
Yeah, because if S&OP pushes a plan down that ignores RCCP, that rough cut capacity the factory attempts to build products, it doesn't have the machine hours for.
Right.
Work-in-process inventory just piles up on the floor, lead times explode, and ultimately customer trust is broken because orders are late. The master schedule forces the organization to confront its own constraints before the raw materials are even ordered.
Which raises a massive operational question for me. We understand where the schedule sits, but how does it know what specific variations of a product to schedule before the actual customer orders arrive?
That is the big challenge.
I mean, if an automotive plant is building cars, how do they know to schedule a blue sedan with a sunroof versus a red sedan with a basic trim package before the customer even walks into the dealership?
Well, the text points to the product structure for this, relying heavily on something called planning bills of material or planning BOMs.
Okay, so a standard bill of material is just a recipe, right? It lists all the physical components and the sequence of operations needed to build one specific end item.
Right, but in environments with high product variation, like automotive or electronics or custom furniture, trying to forecast the exact final configuration of every single unit months in advance is a fool's errand.
You'll just guess wrong.
Exactly. You'll guess wrong, and you will end up with a warehouse full of the wrong materials. So to navigate this, planners use planning BOMs, which the text defines as an artificial grouping of components.
Wait, hold on. That phrase, artificial grouping, is exactly where I had to stop and reread the section.
I'm not surprised. It sounds a bit counterintuitive.
Yeah. If a company is manufacturing real physical objects out of steel and glass and silicon, why would they use a fake or artificial bill of materials? Isn't that asking for massive inventory trouble?
It sounds like a huge risk, but it is actually a mathematical convenience designed specifically to mitigate risk.
Okay, walk me through that.
Let's look at a commercial door manufacturer. They offer hundreds of custom configurations. Guessing exactly which combination of locks, hinges, and finishes the next 100 customers will buy is impossible.
Right, you'd never get it exactly right.
However, aggregate historical data provides a very clear picture. Historically, the manufacturer knows that across any 100 doors ordered, roughly 60% require upgraded security locks, 30% get standard locks, and 10% have no locks at all.
So they don't know which specific door order will get the upgraded lock, but they trust the historical law of averages.
Exactly. The planning BOM takes those historical averages and artificially groups them into a single fictional average door.
Okay.
This artificial door consists of 60% of an upgraded lock, 30% of a standard lock, and 10% of no lock.
Well, you obviously cannot physically manufacture a door with 60% of a locking mechanism.
No, you can't. But mathematically, if the master schedule plans to build 100 of these artificial average doors next month, the MRP system reads that planning BOM and automatically procures exactly 60 upgraded locks and 30 standard locks.
Oh, wow. That's incredibly smart.
Yeah.
So it allows the purchasing department to procure those long lead time materials and the factory to reserve the necessary machine capacity without forcing the company to commit to the final finished variations too early.
Exactly. They stage the components based on probability, but they wait to do the final assembly until the actual firm customer order arrives.
It's like a high-end kitchen doing prep work. You chop the onions, you portion the steaks, and you make the mother sauces before the restaurant opens, relying on historical data of what people usually order on a Friday night.
Right.
But you don't actually fire the steak or compose the final dish until the waiter hands you the ticket.
That deferred commitment is the core value of the planning BOM. And the text also highlights modular BOMs, which operate on a really similar principle. Well, instead of just staging raw materials, modular BOMs allow a manufacturer to plan and build standard subassemblies. So the door manufacturer might build the basic wooden door frames and put them into inventory.
And then just wait?
Yeah. When the firm order drops, they just pull the frame from stock and install the specific custom lock. It drastically reduces the final lead time to the customer while keeping inventory highly flexible.
Okay, so we have these planning BOMs to help guide the material staging, but there is still the mechanical process of translating those broad monthly goals from the S&OP into actionable weekly instructions for the factory.
Right, which brings us to disaggregation.
Yes. The text refers to this translation process as disaggregation. You're basically taking the monthly constrained demand for an entire product family and breaking it down into a weekly constrained demand for the individual items within that family.
The term literally means separating something into its component parts. But this isn't just a casual breakdown. It is bound by really strict mathematical rules. The CPIM text highlights what is essentially the golden rule of this process. The sum of the master production schedules, the individual MPS quantities for all the items in a family, must exactly equal the S&OP production plan for that family.
And the source material provides a very rigid math example for this. So, if the family production plan from S&OP dictates the factory needs to build 460 units in month 1, 450 in month 2, and 410 in month 3.
Right, which totals exactly 1,320 units over the quarter.
Exactly. When the master scheduler breaks that family volume down into weekly schedules for the individual product variations, those weekly item numbers must mathematically hit that exact 1,320 target. No exceptions.
Zero exceptions. If the master schedule adds up to 1,319 or 1,321, the plan is invalid.
Wow.
If we connect this to the bigger picture, this strict alignment is exactly where you see the friction between management's strategic intent and the master scheduler's tactical reality.
Right, because management dictates the overall volume at the pre-S&OP meetings. But a broad volume target doesn't run a factory floor.
No, it doesn't. That's where the master scheduler earns their keep. They have to disaggregate that plan realistically, resolve the daily trade-offs, check the rough cut capacity, and ensure the preliminary master schedule is actually workable and achievable.
So what does this all mean? It's basically the difference between a general and a sergeant.
Oh, I like that.
Yeah, think about it. The S&OP is the general pointing at a map and saying, we will take that hill by Friday. The general sets the strategic objective and the timeline. But the master scheduler is the sergeant on the ground on Tuesday morning. The sergeant has to decide exactly which soldier carries the heavy radio, who takes the extra ammunition, what time they march, and how many rations they consume each hour to ensure they actually reach the top of the hill by Friday without collapsing. The general commands the volume, but the sergeant navigates the constraints.
That is a perfect way to look at it. And to navigate those daily constraints, the master scheduler relies on the master scheduling grid.
Okay, yes. Let's get into the grid.
Once the quantities are disaggregated, they have to be plotted over time to tell the factory exactly when to initiate production. The grid is time-phased, usually laid out in weekly buckets, and it constantly tracks the relationship between supply and demand to project future inventory levels.
So the grid basically functions as a giant rolling mathematical equation.
Exactly.
You have constrained demand, which represents what the company expects to sell based on forecasts. You have customer orders, which are the actual firm orders already on the books.
Right.
And you have the master production schedule, or MPS, which is the exact amount the factory plans to manufacture in a given week.
And tying all of this together is the PA, the projected available balance.
Which is simply the projected inventory sitting on the shelf at the end of any given week.
Okay, spot on. And the core equation running the grid is really straightforward. The ending PAB for any week equals your beginning PAB plus any scheduled MPS receipts arriving that week minus the demand.
And the definition of demand kind of changes depending on the time fence, doesn't it?
It does. It might be actual firm orders in the near term or purely forecasted demand further out. But the subtraction is constant. The PAB is constantly draining.
Okay, here's where it gets really interesting. Instead of just reading the spreadsheet rows from that make-the-stock chase production example in the text, let's look at the actual behavior this math drives.
Right. Let's bring it to life.
The entire grid is built around a tripwire. It's a trigger rule.
Right.
Whenever the projected available balance, the PA, threatens to fall below zero, meaning the factory would theoretically go negative and fail to meet demand, the system is forced to schedule a production run.
Yes. And the text calls this scheduling a lot size MPS.
Right. Once that production batch is scheduled, the system recalculates the math, pushes the timeline forward, finds the next time the balance threatens to go negative, and triggers production again.
The tripwire is the perfect way to conceptualize it. The system allows the inventory to drain down to the absolute edge of a stockout, and only then does it signal the factory to turn the machines on.
Let's walk the listener through the specific text example.
Okay, so in the text-specific example, the company uses a fixed production lot size of 100 units. meaning it is only economically viable to run the machines in batches of 100.
Got it.
Their beginning inventory is 70. Week 1 demand is 50.
So the PA drops to 20.
Right. Now, week 2 demand is 60. If you take 60 from the remaining 20, the math hits a theoretical negative 40.
Oh, so the tripwire is tripped.
Exactly. Because it goes negative, the system mandates an MPS receipt of 100 units for week 2. So the new math for week 2 becomes 20 from the prior PA plus 100 from the MBS minus the 60 for demand.
Leaving a new, healthy ending PA of 60.
Precisely. And the crisis is averted.
You know, the mechanics of this are exactly like managing a personal checking account with overdraft protection tied to a savings account.
Oh, that's a really good point.
Yeah. Your balance, the PAB, is constantly dropping as your regular living expenses and bills. The demand hit the account week after week. If a massive unexpected bill hits and you are about to overdraft and drop below zero, the bank's automated system hits a tripwire. It automatically triggers a fixed lump sum transfer from your savings, your lot size MPS, to keep the checking account solvent. You just let the math roll forward week by week, and the system catches you before you bounce a check.
And the operational equivalent of bouncing a check in supply chain is failing to deliver on a promised order.
Yeah, that's bad news.
Very bad. This mechanical rolling calculation is the only thing keeping inventory levels tightly targeted. The factory isn't building products blindly and hoping they have enough to cover sales. They are building precisely when the mathematical tripwire dictates they will run out. This grid provides the company with visibility into exactly when new inventory will be available. When a sales rep makes a commitment to a customer, they are relying entirely on the ATP, the available to promise calculation, which is derived directly from this master scheduling grid.
So if the grid is wrong, the sales rep is lying to the customer without even knowing it.
Exactly.
Okay.
Which is a terrifying thought.
It really is. Well, we have covered a massive ecosystem today. We started at the broad, low-resolution level of sales and operations planning, looking at how management sets the monthly volume targets. We traced the cascading capacity checks, seeing how rough cut capacity planning serves as a physical reality check for the master schedule. We explored the mathematical elegance of using historical averages within planning bombs to stage materials without committing to final assembling too early.
Right.
We looked at the strict rules of disaggregating family demand into specific item schedules. And finally, we saw how the master scheduling grid utilizes a mathematical tripwire to trigger lot sizes, preventing the factory from overdrafting its inventory.
The architecture is incredibly robust, but, and I want to leave you with this thought, it carries a fundamental vulnerability that any supply chain professional must recognize.
Okay, what is it?
Well, the CPIM text explicitly warns that maintaining the master schedule requires a consistent periodic review and update cycle alongside extremely timely transaction processing.
Because it's all based on data.
Right. The master schedule is an abstract model of a physical reality. It relies entirely on the data it is fed.
The map is not the territory. If the data is flawed, the model fails.
Exactly. Consider the friction when human error or sudden real-world supply chain chaos disrupts those timely transactions. Imagine a master grid that is perfectly calculated, the disaggregation is flawless, the tripwires are set. But out on the physical factory floor, a forklift driver accidentally ruins a pallet of raw materials and fails to log the scrap into the system. Or a supplier's truck breaks down, but the receiving dock doesn't update the late arrival in the software.
Oh, wow. So suddenly, your perfectly calculated math is directing a factory based on an illusion, a ghost inventory.
Exactly. The grid is triggering production based on components that simply do not exist. This forces an organization to constantly ask how they build physical verification and resilience against the vulnerability of the very mathematical grid they rely on to survive.
Because the math doesn't make mistakes, but the physical world definitely does.
It absolutely does.
Well, thank you for joining us on this deep dive into the APCS CPI materials. Keep looking closely at the invisible schedules running the systems around you, and never stop questioning how the perfect math holds up against the messy, unpredictable friction of the real world.